Welcome to another video on digital electronics. In this video, we'll be seeing what is a binary adder and one of the forms which is called as a ripple carry adder is what we're going to see with a numerical example. So what is an adder? Adder adds multiple bits. Like half adder only adds 2 bits. Full adder only adds 3 bits. But if you want to add a number or decimal number which has got multiple number of bits, for example, say I want to add decimal number 32 with a decimal number 54. So this decimal number in binary is going to be a larger number with multiple number of bits. So this maybe say has got 5 bits. This has got 6 number of bits and so on. If you want to add these numbers, then what you require is you require multiple full adders, right? So because this is going to add only full adder is only going to add 3 bits, of which 2 bits are for the addition and the third is a carry it is adding from the previous addition, right? So let's see how a binary adder works. Here we are taking an example of a simple number which is a 4-bit number. So I have 4-bit number, two 4-bit numbers which I need to add. So let's name those numbers. This is A and this is B. A is called as an augend. A is called as an augend and B is called as an addend. Addend. Right? So this is augend, this is added, and the result will be sum and carry, of course. So we have, since we are adding 4-bit numbers, then how many full adders are required? 4 full adders. Full adder number is equal to same as the number of bits. If I had to add 5 bits, then I would have 5 full adders. 6 bits, 6 full adders, and so on and so forth. So what is the first adder, full adder do? This is your first full adder. This first full adder will add a is my number. It has got 4 bits. So let's name all of those bits. So this is A0, A1, A2, A3, right? 4 bits. Similarly, I have B, which is also 4-bit number. So let's write down all the bits for B. B0, B1, B2, and B3. For the very first addition that we are doing, for the very first addition where I'm adding the LSB bits of A and B, right? I'll take an example simultaneously here. I will scroll this down a bit. So let's say my number is 1011. This is my A and my B is 0011, right? So if you are well versed with binary now, you know this number is 3 plus 8, that is 11, and this is 3, right? So eventually your answer should be 14. So this is your B. And this is A0, A1, A2, A3, B0, B1, B2, B3, right? So this is how addition we are taking. When we are adding the first 2 bits, the LSB, is there any carry that we are adding here? No. So the very first carry of the full adder, since full adder has got 3 inputs, right? It adds 3 bits, 2 bits of the sum and the third of the carry. So there is no previous generation of the carry that is coming here. And hence the C0, the carry 0 bit is always grounded, is always grounded, right? So if you're making a circuit on the hardware also, you will notice that it is always grounded. This is C0. And what is the result of this first addition? The first addition will give you sum, which is S0, and it will generate a carry, which is C1. And this carry will be rippled ahead to the next full adder. This full adder will do what? See the addition here. The sum is 0, the carry is 1. 1 plus 1, sum is 0, carry is 1. So sum here will be 0 and the carry here will be 1. Next 2 bits which I am adding is these 1, 1 and 1. So by full adders, last row, if you remember, all 3 are 1s. So for 1, 1, the sum is 0, carry is 1. That's sum 1 plus this sum 1. Sum is also 1 and carry is also 1. Right? Sum is also 1, carry is also 1. So I will have my sum here S1 as 1, and the carry which is generated here, which is C2, is also 1. This is 1, right? Okay. Let's come to the third bit of addition. 0 plus 0. The sum is 0, carry is also 0. That sum 0 plus this 1. Sum is 1 and carry is 0 now. So I have my sum 1, S2 as 1, and the carry which is getting forwarded to the next full adder is 0. The carry is 0 here. And the last bits which we are adding is this plus the carry. Carry is 0. 1 plus 0 is sum is 1, and sorry, and the carry is 0. So here I see S3 will be 1. S3 is 1, and the carry that you have C4 is 0. Now, if you see this bit that you received, the answer that you received, this was 11, this is 3, answer should be 14. If you check 1, 1, 1, 0 in the binary table, this is 1, 2, 4, 8. 8 plus 4, 12, plus 2 is 14. So you get the same answer of the decimal addition that we are doing. But this is how binary addition works, and this is how carry is forwarded, right? So this was binary adder. The number of full adders increase. The last thing which I want to point out is in this first adder position, the first adder that you have, it is not mandatory to have a full adder. Why? Because there is no carry here, right? So eventually you are adding only 2 bits. And adding 2 bits is done by half adder also. So you can always have a half adder in the place of a full adder, only one. Which means if you want to add two 15-bit numbers, then how many full adders are required? If that is a question, then the precise answer should be you require 14 full adders plus one half adder. Because the very first 2 bits that you're going to add is never going to have a carry, right? So one half adder will do that job, and the rest of the 14 bits should be added by a full adder, because there might be a carry generated from the previous addition that is coming. So this is the most precise answer that one should have. So I think I have made my point very clear here. I hope there is no doubt. I will stop this video here. Thank you for watching.